and the botanists as well. So he began to believe that all organisms come from a common descendant. Darwin also came to the conclusion that certain animals have something called the vestigial structures, okay? Structures that were functional at one time but non functional at this time, such as the whale and its hip bones or any limb bones that the whale may have. For example, whales that existed before whales of today, some whales still had small legs, that they would use to flick off parasites or try to draw a mate, and they had to use those in order to survive. As the whale became bigger and the whale became older, those things are not useful anymore. An example of this on us, well, there's two examples. One is our hip, not our hip, our tailbone, which was compressed once we stopped swinging from trees and we began to walk upright. And our appendix, we really don't know what our appendix has been used for. Okay, so those are some examples of structures that led the history of evolutionary thought to believe that maybe all of us come from a common ancestor and an ancestor that can influence our evolution. So, evolution. We've already went over the definition of evolution in different videos and how that is just organisms changing over time and taxonomy with Carolus Lanu and binomial nomenclature, and how these things are used in order to classify and group organisms based off their relationship to other organisms. So I'm really not going to spend a lot of time on this slide. Excuse me. Fossil record. So we have this information about organisms existing because we have something called the fossil record. If you've ever been to the Field Museum in Chicago, downtown, you see a plethora of fossils, and there's one really cool exhibit where they have a bunch of extinct mammals that existed and extinct ocean life that existed, and they have the fossil record right there, comparing it to other animals of this time. Okay, one of the fossils that we're trying to still find, which you see right here, those words are the missing link. We're still missing that one fossil from that one organism that will link every single organism together and thereby proving the theory of evolution and making it a scientific law. So it's important to remember that the fossil record is the collection of all the fossils that have ever been discovered on Earth. So if we discovered it on Earth, it's in the fossil record. And then we have something called a transitional fossil because there are different organisms, such as the Archaeopteryx, which you will see right here. That's how you pronounce that word, Archaeopteryx. And then there's another one, Ambulocetus. They were links between Archaeopteryx being one of the dinosaurs that can sustain flight in its relationship between birds, and Ambulocetus being the relationship between whales and former land mammal ancestors. Okay, so we have animals that are transitional animals that they may not fit within either classes, specific niche, but they are important because they represent the transitioning from one member of the family to the new member of the family. And then, so what can we learn from fossils? You can learn how the organisms moved, how the body worked, the relationship of other organisms that lived years back to organisms that exist now, what type of things that it ate. Sometimes when we find organisms, we find particles of food in their stomachs, if their stomach has fossilized, or what they are eating at the time, because plants fossilize in different bones as well, and how old the organisms are. We have proof that organisms existed on Earth up to 4 billion years ago because we have found fossils